Back to the example of the elevator, the student, and the scale. Let's assume that as the elevator is being attached to a rope, and that rope is exerting force through an electric motor to let the elevator go up and down. What if, when we are on a certain height, we cut the rope of the elevator and the elevator is free falling in that case? What's gonna happen for the student and the scale inside that elevator? What's gonna happen in this case? This student and the scale are in free falling. In this case, there is no normal force being exerted from the scale on the student. The whole system, which is the elevator cabinet, the student, and the scale are free falling. Free falling means the acceleration of the whole system or all the objects encapsulated within the elevator are falling in the gravity acceleration. If you do a free body diagram, there is no normal force on the student, only F gravitation is pulling the student downward in this case, which means the acceleration equals the gravitation. Mathematical wise, if we do the net forces analysis, F net equals Fg, and we know F net equals the mass by acceleration, would equals Fg. Fg we know equals mass by gravitational acceleration. In this case, acceleration equals gravitational acceleration for the whole system. So that's what happened in free falling. There's no normal force, and the weight of the student would equal the gravitational force. A summary for the gravitation section. True weight, we discussed, equals the gravitational force to equal to mass by gravitational acceleration. Newton's law of gravitation, Fg equals the gravitational constant by the mass of object A by the mass of object B over the square of the distance between mass A and mass B. Gravitational field strength equals G equals the gravitational constant by the mass of the source over the distance squared. Apparent weight equals minus the normal force. As a hierarchy diagram for the gravitation section that we discussed through the past few lectures, gravitation is distributed into gravitational forces, the mass, the weight, gravitational field strength, and we discussed all the details and the equations related to each of those streams. And we said there is a gravitational forces and there is other types of weak and strong forces in physics. We discussed the mass is can be equal. Either you can find the mass through the inertia using acceleration, or you can find the mass through the gravitational forces. And we said the weight is very important when you are talking about objects in space and the gravitational relation between them. And we talked about the gravitational field strength, and we discussed the equation of gravitational field strength and all the details related to that. For now, we are ready to move to our next chapter, talking about work, energy, and circular motion.